So today's lesson 7. We've gone over assignment 2. So if you're watching the class asynchronously, assignment 2 has been posted to Blackboard. And in the week 7 folder, we've logged into Padlet with our school Microsoft credential. And then we're in our Padlet brainstorming board. And we're making a few notes about what we already know about SSL. Okay, so lots of notes that it's around secure connections. Diana's explanation is good. Yeah, it's specifically around encryption. Yeah, Shubnik's mentioning that as well. So if you haven't added a note, yeah, click in here and tell us what you think. Yeah, you're right, Justin. It should be the default now. All right, that's a pretty good list. Has anybody ever bought or installed an SSL certificate before on a website? A few no's. Okay, a lot of no's. Now there's another really important reason another really important reason now that we need SSL. So not only does it encrypt, as Diana and Shubnik mentioned, not only does it encrypt all the traffic, because normally HTTP sends all traffic in plain text. So when my browser, I'm sending a request to padlet.com, as that request travels through the internet from my service provider all the way to the Padlet to where the IP, where the padlet.com server is, all that traffic is in plain text. So as Radia mentioned, yes, and Meg, it stands for Secure Sockets Layer. So SSL will encrypt any traffic, any data I send from my browser to the server, as well as any data that comes from the server back to my browser. SSL encrypts it. So that allows for secure connections. So we used to have SSL for, pages that needed to be secure. So credit, where we were entering, credit card details on a payment or on a login form, for example. But it's not just used for that now. So there's a couple other really important reasons I want to mention, and maybe somebody can add to the board. So we'll have a look at this article, and really has to do with Google and browsers. Diana, how secure is what? Can you clarify your question a bit? Well, it's certainly more secure than no SSL, because at least the traffic is encrypted, and we have various levels of encryption we can use with SSL. They've been around for a long time, and it is still recommended as best practice. So not only is SSL important for security, and I'll sort of come back to your question in a minute, Diana. I've put a link up here if you refresh your week 7. But SSL is also important for a couple other reasons. Even if you're only building a static site that was just pure HTML and CSS. Okay. So this article talks about SSL, uses a valid digital certificate. But part of the other reason that it's important is that search engines, particularly Google, they now factor SSL into their search engine rankings. So two sites that are built exactly the same way, if one has SSL and one doesn't, the one with SSL is going to be ranked higher in Google search results. That's one thing. The other thing is that our browsers will mark sites, particularly Chrome. Let me open up Chrome. So most sites nowadays, the vast majority is that our sites use SSL. And we can see this. So in Chrome, we see the little lock. In Firefox, we see the lock as well. And if we click on it, we can actually view information, you know, who's the verifying certificate authority. You can actually view the SSL certificate. Here it is, who is it issued by, and you can see the digital signature verifying its authenticity. If we go to a site like this is just a, let's see. This is just a blog I had to throw up for a course I'm taking. Now, I didn't bother using SSL, so Google actually marks your site as not secure. So you may think, you know, if you're just building a static site, oh, I'm just going to build an HTML, CSS site. There's no data transmission. There's nothing secure. I don't really need an SSL certificate. Well, yes, you do, because otherwise your browser is going to mark the site, particularly if it's Chrome, it's going to be marked as not secure, which may scare a lot of users away. So SSL is a best practice now for any kind of site, regardless of whether there's actually sensitive information in there or not. It doesn't matter anymore. So there's a few ways you can get SSL. Many servers now offer a free SSL certificate called Let's Encrypt. So you can get them here, and many web hosting companies support Let's Encrypt. So these are actually free. So for example, with one of the hosting companies I host with, if I pick a domain, so I can just enable a Let's Encrypt SSL certificate directly in my hosting panel. I click it, I get a free SSL certificate. Other times we buy them. And Diane, I'm going to come back to your question about how secure they are. Justin, good question. I will come back to that. So let's look. So I like to buy my SSL certificates here from Namecheap. So we can see what they offer in terms of security. They start for as little as $5 a year here for a single domain, for example. For organizations in e-commerce, so if we've got multiple domains, we can get other ones. The other thing that some of the premium ones have, for example, is they have higher levels of encryption, and they often have, so if we compare a couple of these, they also come with different amounts of warranty, for example. So this has extra validation, higher assurance, a much higher warranty, for example, but the encryption levels are actually the same. So oftentimes if I'm using a server that doesn't use a Let's Encrypt, I'll often get one of these inexpensive ones, you know, 10, 12, like the Essential SSL or the Instant one I will get. So when you set one of these up, there's some back and forth, some go-between between the certificate issuer where you buy it here and the hosting company. So I'll show you what this looks like. So here's my Namecheap account. I've got some SSL certificates here. So I can buy a $12 certificate here, but in order to create the certificate, I have to go to my hosting company and I have to ask them what's called a CSR, a certificate request. So I ask them for a certificate request. Oops, actually, that's not a good example. Let's see. So they need information about the organization that owns the domain. And then on the web server, they generate one of these certificates. So then I need to take this information over to the company where I'm buying the certificate, and I have to verify the domain and include that request in the certificate. Then it takes a few minutes. I download the certificate. I have to upload it to my web server and get a server administrator to install it. The server certificates look something like this. If I go into a client site, let's see. So here would be an SSL certificate so when I download it, I get a zip file with a bunch of these kind of encrypted files inside. So if I open one, it looks something like this. So that's the actual certificate that has to get installed. Now, many hosting companies, they'll sell you their own certificates, but they're very expensive. So for example, I know, Justin, like I know you host on GoDaddy. GoDaddy doesn't offer Let's Encrypt, and they also won't let you buy your own cheaper certificate somewhere else. So if you want an SSL certificate on GoDaddy, I'll come to those questions in a minute. I think GoDaddy SSL certificates are like $70 a year. They're quite a bit more expensive. So let's see what they offer. Yeah, so one website on GoDaddy is $85 a year, whereas on Namecheap I can get one for $11. Okay, I'm going to come to your questions because these are good questions. Does SSL check what's on the site? No, it doesn't. There's no verification, so it's not confirming what's on the site, and it's not providing any kind of other security check saying that you followed best practices and secured the website. That's still up to you. When you purchase them, so it's like buying a domain. You can choose, and typically they give you a break depending on if you buy more than 1 year, then you get a discount. So here, you get a discount for 2 years. For 1 year, the price is a little more. So you have to pay attention to the renewal notices. Some companies allow you to auto renew. Other companies, you have to go ahead and do it on every renewal. So it's important that you ensure you don't let them expire, because otherwise then users on your site will get notice that the SSL is expired and the browser will tell them the site isn't secure. So you do have to monitor them. So basically I have a spreadsheet with all my client domains where I keep track of the annual expiry date of the domain names and the SSL certificates. The good providers, they send me, so a company like Namecheap, they send me renewal notices, and I make sure that I pay attention to those because I don't want my clients' SSL certificates to expire. So if you can use something like Let's Encrypt and your host supports it, great, that's the easiest thing. There's no cost, there's no setup. If you do need to buy them, then I've found that using Namecheap, they're a really good provider, because that's not their responsibility. They have no way to do that. They're not performing an audit. There is something else. It's not related to SSL. There is a service like this. I'm not sure if this is the right site. There are some sites that claim they will audit your site for security and give you some sort of seal you can put on, but those are not cheap. Yes, absolutely. Yes, so typically I pay for the SSL certificates, but yes, absolutely, Justin. I then bill my customer for them. And I mark up the price a little bit because there's a bit of work on my end in setting them up. So if I pay $11 for the certificate, I might charge, let's say, $30 or $50 because it takes maybe a half an hour of my time to go ahead and do the renewal and the setup. So absolutely, Same with the domain name. So typically if I register a domain name and an SSL certificate, those things come up for renewal at the same time if I buy them together. So I look after the renewal, and then yes, I bill my customer, and I also bill them for an annual hosting renewal. For sure, you don't pay out of your own pocket for those things. Obviously, if I use Let's Encrypt, there's no cost in this case, so I don't have to charge anything. But also better, you know, why have your customer get an $85 certificate at GoDaddy if you could buy them a much cheaper one somewhere else? These are great questions. Now on our website, actually I'm just going to go back to Diana's site for a minute. On your projects, when we're using Azure, we've actually got SSL already. You'll notice here, we've got SSL. And if I take it out, let's see what happens if I try and go load the HTTP version. It actually redirects. And the reason is we didn't buy an SSL certificate, but Microsoft already has an SSL certificate covering AzureWebsites.net. And it also has an automatic redirection on their web servers. So if we try and get around our SSL certificate, it just redirects back to the encrypted secured version. Now, if you bought your own domain and hosted it on Azure, then you have to get your own SSL certificate and also force all our requests. Now, the code for forcing the requests, that's actually in our project already. And we can open up our game store and we can see how this works. Okay. So let's open up our store, our video game store. Put my password back in. And if we go to our startup, actually, if we go to our startup, the reason why whenever I try and load any page in Diana's site without HTTPS, I just get redirected back to the secure version, is because of this line of code here. It's in our startup file. For me, it's on line 54 in the configure method, where it says use HTTPS redirection. And that line of code got added when we set our project up because there was a checkbox that said in the create project window, there's a checkbox that says use SSL. So when I created my project, I'll just go ahead and create a new one or load that screen. So if I create a new project, and I pick a web application and give it a name, you'll notice this checkbox. It defaults to unchecked, but if we check it off, and it remembers what we picked in our last project, configure for HTTPS. Whoops. I don't really need this project. Cancel it. Checking that box is what gives us this line. So automatically now, anytime a user, if they try to go around our SSL certificate, they get redirected back into the encrypted version of our page running HTTPS, which is good. So I'm going to launch our site. I've also got a separate demo site running. And I'll show you what we want to implement today. So what we want to implement is Google Sign-In. So I can come to the site as an anonymous user. When I click Login, so you'll notice on our game store, on the login screen, it says, use another service to log in. No external service is configured. So we want this to change. So instead, it's going to show Google. And if I click on the Google button, I'm actually, maybe I'll do it in a private window. Let's see, I'll go here. Whoops, that wasn't very smart. Didn't mean to close it. So I'm going to log in here with Google. Pick a Google account. It's going to authenticate me through Google, and then it brings me back to our site and automatically logs me in with my Google account. So this is what we want to implement first. We're going to work on this together. And then once we have the Google login working, I'm going to put you in breakout groups, and in your groups, you're going to try to implement a second external provider. So this is where we're going with this today. And then you'll also need to implement this into your assignment 2, part 1. So we need to go through the process. I'm going to kind of walk you through what we're going to do to give you an overview quickly. So this slide deck is on Blackboard. I'll go through it quickly, just kind of at a high level, and then we'll go through it together. Okay. So we've already got our built-in register and login page. And the neat thing is to get this Google button to show up, we don't really have to write a lot of code. Our application's already configured basically in part to use Google, Microsoft, Facebook, as well as Twitter. And there's a link here that you can use in the next part of class to help you with implementing either Microsoft, Facebook, or Twitter login. We'll do Google together. So first thing we'll have to do, you don't need to, it's kind of one and the same, Diana. You don't need to users don't need to register in this case. Yeah, they just log in. So we're going to have to go to the Google Developer Console. So you'll need a Google account for this. And first we'll have to configure their consent screen. And in here, we're going to pick external. So it's not just any user in our organization, but it's going to be any Google account we'll allow in. We'll then have to fill out this consent screen where we put in a name of our project. If we wanted to, we could put in a logo. And then we need to authorize the Azure domain. We don't need to for today, but if we don't authorize the Azure domain when we publish our site to Azure, the Google login won't work. It's going to say the domain is not authorized for Google login. So we'll have to add this into this authorized domain area. And don't worry, I mean, we're going to do all this together. I'm just giving you a bit of an overview of what we're going to be doing. We're going to create an OAuth client ID. We'll give it a name. And then we need to add the redirect URIs. So this is so that after we log in with Google, Google knows what URL, where do they send the user? And we'll want to put in both our local and Azure site. So that way the Google login will run for our app both in Visual Studio when we're running it locally, as well as when we publish it to Azure. So we'll take both our domains, and then the URL that's built into the library we're going to use will be /signin-Google. So we'll need to add those values, those URLs, into the Google panel. Once we're all done, Google's going to give us a set of API keys that'll have two values, the client ID and the client secret. And we're going to need both of these in order to connect our web application to this Google sign-in authority. So we're going to take those keys from Google and we need to add them to our project. So we can do it in one of two places. The simple place is we can just dump them into appsettings.json, and that way it will work both on our local machine and on Azure. This is not really recommended best practice. I know we have our database connection here. It's not recommended. Typically with sensitive values like this, we actually should store them in two places. Locally, we have a secret key vault on Windows, and then we have a separate configuration section on Azure. And that allows us to have different values both locally and live. And these values are encrypted. So we're going to first put them in appsettings.json, and then I'm going to show you the more secure place, the more secure way of storing them in the key vault, which is what I would recommend. So to store them in the key vault, we use the package manager console, and we run a few commands. We initialize the user secrets section, and then we set up two user secrets. The first one we'll call Google Client ID. The second one is the Google Client Secret. And we just copy and paste those keys from the Google console. To then configure the same values in Azure, we go into the configuration area of our website, and we create two new settings. So for your assignment, you'll need to do this. So you'll click a new setting, and then you put in the name and the value, first for the client ID and then for the client secret. Then we need to install a package from the NuGet Package Manager. So it's the ASP.NET Core Google Authentication Library. This has all the code that will do the Google sign-in for us. And then we need to add, in our startup, we need to add the Google service and say read the keys either from appsettings.json or from our key vault. When we add this code in this package, that's what will replace the text here with the Google and enable the Google button. So that makes our button visible. And then after we create, basically after we try to register or log in with a Google account, this is the screen we'll get. We'll go through the Google login box, and when it returns to our site, we'll get a message saying we've successfully authenticated, and it will confirm the Google email address that we used. In terms of the database, when we log in through an external provider, it doesn't actually get saved to the ASP.NET users table. ASP.NET users table saves users who register through our own website. Instead, we have this ASP.NET user logins table. So this is what the record will look like. It'll show the login provider. So what service did the user come from? We get a key from that service, and then we get a user ID. So we can see in our database which users have registered with our site and which users have registered with the third-party provider and which provider. And this table, this NuGet package that we're going to install, it does that automatically for us. So we don't really have to write much code other than this block here. We basically just have to set things up with Google, which works pretty well. Does anybody have any questions about the process? All these slides are on Blackboard in the Lesson 7 folder, so you have it with all the screenshots as a reference to use for your assignment. But we're going to go over this, we're going to actually implement the process together in the next part of class, and I'll record it as well. I'm not seeing any questions, so I'm going to stop my recording and screen share for now. Let's take a 10-minute break, and we'll come back at noon, and then we will actually go through and implement this process one step at a time. Okay? So we'll start that in 10 minutes. Let's take a break.